Hello, Matt here from ChemistryStudent.com. In this video, we're going to look at the mole. We're going to talk about what a mole in chemistry is, where the idea comes from, and the value of Avogadro's constant. Using moles and mole calculations have been covered in separate videos. Check the links in the description below. Atoms are very small, meaning even in a small sample of a substance, there are huge numbers of atoms and molecules in it. Referring to the actual number present isn't realistic, and instead a unit called the mole is used. 1 mole has a value of 6.022 times 10 to the 23. Just like 1 dozen of something equals 12, 1 mole of something equals 6.022 times 10 to the 23. In the same way as 2 dozen atoms means 24 atoms, 2 moles worth of atoms means 1.2044 times 10 to the 24 atoms. 2 times 6.022 times 10 to the 23. Equally, half a mole's worth of atoms would be 3.011 times 10 to the 23, half of 6.022 times 10 to the 23. When dealing with amounts in chemistry, it is nearly always a mole's worth of something we are referring to, sometimes described as molar quantities. For example, with equations for reactions, it is actually the number of moles of each reactant and product involved that the ratio in the equation is referring to. The equation 2H2 plus O2 forming 2H2O means 2 moles worth of H2 molecules react with 1 mole's worth of O2 molecules to form 2 moles worth of H2O molecules. This is why equations can sometimes have half values in. As we aren't actually referring to half a molecule, we are referring to half a mole's worth of that molecule. 1 mole's worth of a molecule will contain more than 1 mole's worth of atoms. For example, 1 mole of hydrogen, H2 molecules, will contain 2 moles of hydrogen atoms, as each molecule contains 2 atoms of hydrogen. Meaning to make 1 mole of hydrogen molecules, 2 moles of hydrogen atoms are needed. 1 mole of water molecules, H2O, will contain 2 moles of hydrogen atoms and 1 mole of oxygen atoms, 3 moles worth of atoms in total. The value that 1 mole refers to, 6.022 times 10 to the 23, is called Avogadro's constant, named after a famous Italian scientist called Avogadro. The number itself was never actually proposed by Avogadro. It is named after him, however, because he laid the foundation for the idea of the mole. Avogadro proposed the idea that the volume of space occupied by a particular number of molecules of a gas is the same as the volume of space occupied by the same number of molecules of a different gas, at the same temperature and pressure. This idea was later linked to relative atomic mass, and the link showed that if the masses of 2 samples were in the same ratio as their relative masses, the number of atoms in each sample would be the same. For example, in 1 gram of hydrogen, there is the same number of atoms as there are in 12 grams of carbon, as the masses of each sample are in the same ratio as their relative masses to each other, 1 to 12. It was then discovered, much later, that when the mass of an element in grams is the same as its relative mass, 1 for hydrogen, 12 for carbon for example, the actual number of atoms present is, you may have guessed this one coming, 6.022 times 10 to the 23, and this value was called Avogadro's constant, and is now used to describe 1 mole. So, to summarize, the mole is a unit and term used to describe 6.022 times 10 to the 23 of something. The value 1 mole refers to is known as Avogadro's constant and comes from the number of atoms of an element present in a sample of the element that has the same mass value in grams as the element's relative atomic mass. For example, hydrogen has a relative atomic mass of 1, meaning in 1 grams worth of hydrogen, there are 6.022 times 10 to the 23 hydrogen atoms. Carbon has a relative atomic mass of 12, meaning in 12 grams worth of carbon, there are 6.022 times 10 to the 23 carbon atoms. Balanced equations in chemistry are based on the molar ratios of reactants and products. For example, 2Na plus 2HCl to form 2NaCl plus H2 means 2 moles worth of sodium atoms react with 2 moles worth of HCl molecules to form 2 moles worth of NaCl and 1 moles worth of H2. 1 moles worth of a molecule will contain more than 1 moles worth of atoms. For example, 1 mole of H2 gas molecules will contain 2 moles of hydrogen atoms, as each molecule contains 2 atoms of hydrogen. 1 mole's worth of water molecules, H2O, will contain 2 moles of hydrogen atoms and 1 mole of oxygen atoms. 3 moles worth of atoms in total. I hope you found this video useful. Please check out other relevant videos in the links given in the description below and visit chemistrystudent.com for free notes and revision materials.